Hello, this is Calculus 2 on April 9th, 2020. I have just got a question. Someone is having trouble with the integral of sine to the fifth power of x dx. Of course, I'm not going to do your homework, but I thought, hey, how about I do something like the integral of cosine to the fifth x dx? It's remarkably similar, but what the heck? Anybody who actually watches these videos should get rewarded. Here's the trick. The trick is that the cosine is to an odd power. If it's to an even power, like that example at the end of the notes with sine to the fourth power, it's awful. To an odd power is delightful because we can call this cosine squared x times cosine squared x times 1 cosine x dx at the end. And we all know that sine squared of x plus cosine squared of x equals 1, no matter what the x is. That's really the Pythagorean theorem in trigonometric language. So this whole integral can be turned, I can turn cosine squared into 1 minus sine squared. And I can turn the other cosine squared into 1 minus sine squared. And then we have this cosine of x dx. So now I can let u equal just sine, not sine squared, just sine, so that du is cosine of x dx. And so here is our du, and these turn into 1 minus u squared, 1 minus u squared. Now, I know what you're thinking. Now, this is why we had to do all that other stuff about basic integration techniques. This is the good old-fashioned multiply it out, and we FOIL this. We multiply this out. We get 1 minus 2u squared minus u to the fourth du, and that becomes u minus 2u cubed over 3 minus u to the fifth over 5 plus a constant. And so our final answer is just going to be sine of x minus 2/3 sine cubed of x minus 1/5 sine to the fifth of x plus c. And so this is the trick. Anytime you have sort of the ability to turn all of your sines into cosines with one left over, or all your cosines into sines with one left over. If it was sine to the fifth times cosine squared, that would be great. It would just be we would one of the cosine squareds. As long as one of them is odd, we can shift all of them over. This whole formula allows us to shift sort of two at a time. And so if we have one left over, we can have that be our du, and the u substitution works well. Have a great